Lecture 35, DevOps, but operations. So let's imagine we've got our services up and running and they do the thing, capital letters, they're supposed to do. A good start, but we need to keep it running. How do we know if there is a problem? Well, we do that with monitoring, and if we see a problem, alerting, or in the words of Admiral Adama, action stations set condition 1 throughout the ship. Okay, that presupposes, of course, that we have some idea about what to do when it comes to monitoring. Monitoring is surprisingly difficult. There's no one-size-fits-all solution to the things that we want to do when it comes to monitoring, so we're going to have to make some good decisions about this subject. Applications have health checks, yes, but how basic or how complex should they be? In a very, very basic version, they just respond with an okay response when you connect to the health check endpoint, and it tells you, yep, it's alive. But that's maybe not enough, right? A more realistic health check should see, can the system do useful work? Can it reach its database? Is it able to actually do useful work, right? A service that's up in the technical sense and cannot reach its database can accomplish nothing. So that's probably not useful, right? So we should probably consider that unhealthy state. You could also consider automating the basic workflow. And that is going to be users can log in and they can see their data, and there exists test tools where you can record a workflow, and it will click here and enter this text here and submit this request and then get a response. And that sort of thing would actually be a much better indication about what the experience is like for users, because services responding to ping or responding to a basic health check or whatever is not as meaningful as whether or not a user is actually able to log in. The other thing is that a simple health check that verifies that an app can respond or reach its database won't show us a performance problem. Yes, if it's 10 times slower than normal, it does work, and in the sense of functional requirements versus non-functional requirements. Like, yes, the functional requirement of login is fulfilled, and the non-functional requirement of logging in less than one eternity is not fulfilled. But as far as the user is concerned, they don't really care whether they fail to log in because it just returns a no response immediately, or it times out. They're equally unhappy. So there's a lot of things that we could look at in terms of monitoring that might be interesting in terms of performance. So one of them is CPU load. If we're seeing that the CPU usage is very high, we're being limited by our CPU, that's probably a concerning situation. Memory utilization, disk space, disk I/O level, network traffic, all of those things are actually potentially interesting in terms of what is being used. And we touched on some of this earlier when we talked about identifying, say, where a bottleneck is. If we see that disk I/O is a limiting factor, we identified that by monitoring for it, ideally. And then clock skew, how much do different services disagree on what time it is? That is one potential problem when we're trying to get various things to coordinate. If we have different databases that are trying to implement a distributed transaction, something, if they don't agree on what time it is, they might spend a lot of time arguing about who went first. But queue lengths is a bit more straightforward. If we have a large queue of requests that are not being handled, or a large backlog of events that need to get processed, that's kind of concerning, and it's an indication that we need to do something about it. And then application response time is kind of holistic. If we are trying to complete a request and the response time is really long, it doesn't tell us necessarily what the root cause is, but it's still a sign that we need to investigate and figure out why. Now, maybe the root cause is CPU load. That's the reason why the application response time is slow. That would be okay, but it's still, again, outcomes focused. So we covered a lot of these ideas when we talked about profiling and queuing theory to sort of help us understand what to measure and how to measure and those kinds of things. And this is the second time which I've mentioned that you probably want to have a dashboard of some sort. We talked about it, when we were observing operations and giving an overview of all the systems. It's a little bit too late now for me to say, you should take a technical elective in the future, because most likely you are a 4B student watching this, so there is no future term in which to take these kinds of things, and so you can read up on it if you're interested. Information dashboard design is kind of a cool thing. Maybe you want to take it as like a graduate studies course or some sort of continuing education. But it's a little late for me to say, you should take this course next term. With that said, multiple systems are going to be interesting to monitor on a dashboard. You need to get a nice overview of the data that you're looking at without it being too detailed or too vague. And it has to be sort of efficient to take a look at it and understand what you're going to do. But realistically, dashboards are not really used for detecting an incident. You're not paying somebody to stare at the dashboard and press the red alert button if something goes out of a preset range. What we're actually looking for is automatic monitoring. The dashboard is just helpful when somebody does take a look at it to get a glance at what's going on, what is the overall system state. And here are some potential alert conditions that you could imagine, right? You could think about this kind of thing as just examples, but CPU usage exceeding a threshold, but you want that for a certain period of time, right? If you receive an incoming request and it makes the CPU go to 100% while you process it, and then it drops down after 0.3 of a second, that's fine. That's not a problem. CPU usage is not too high. It's not something you should worry about. But if CPU is consistently high, that is a problem. That is something that you want to take a look at. Increased rate of error logs over a period of time. So when you're logging a large number of errors, that is going to maybe be an indication that something is wrong. Maybe the errors result from being unable to reach the database, or some other service reporting that it has too many requests, something like that. A service that has restarted many times recently. Services that are restarting, they might be failing to start up for some reason, and retries, or it might be it crashes. I've seen it crash because it runs out of memory and it gets killed by the out of memory thing, and then the service restarts and the request is submitted again and it crashes. So that's kind of an indication that something is wrong. Similarly, queue length being very long should also be fairly concerning. If there is a long backlog of requests, or if there is a large amount of data that we're going to process, then we should be worried about that. Similarly, taking too long to complete a workflow, we've already touched upon. If logging in takes too long, it's going to be a big indication that the user experience is currently degraded, regardless of whether or not things are healthy on the technical side. Now, interpreting alerts is hard, though, right? Like seeing elevated queue length or something may or may not indicate a problem. Context, as we discussed earlier, is key. CPU usage being high may not be a problem on its own. If CPU usage is consistently at 80%, we may be keeping up with the workload. It's just an indication that we're close to the maximum, and at some point we will need to provision more CPU, and that will be okay. If CPU is consistently at 100%, we should be worried that our performance is limited by CPU availability. If queue lengths are long, it might only be a problem if a certain response time is expected. Merely having a really big backlog of work to do isn't a problem unless it means we're missing some deadlines or being unable to do other things. If we are transferring a large amount of data from one system to another or something like that, having a large queue as we just sort of process it, maybe not slowly, but process it at a methodical pace, Could be perfectly fine, perfectly normal. We've done a big database resync between different services. We're sending a lot of data to the data warehouse. That might produce a larger backlog, and that's okay. From my own experience, billing day, if we're trying to bill a lot of customers on the same day, there's a backlog of recording log entries related to that. That's fine. That's kind of what we should expect. But outcomes focus does matter. As I say, if it takes too long for users to log in, they will get frustrated. The other thing and I want to give some Sir Arthur Conan Doyle nerdery here with Benedict Cumberbatch kind of homes here, is remember the lesson from The Adventure of Silver Blaze. The dog that did not bark was a clue as to who committed the crime. Setting minimum thresholds for things may identify a problem as well. If nobody has logged into your application, just as an example, for an unusually long time, that might be a sign that something is wrong with the login process, right? You're looking for things that you expect to happen that are not happening. And there may be other reasons why this is the case, right? It might be that it is New Year's Day and it is a Sunday, so nobody is logging in on your application because it is both a Sunday and a holiday, and therefore relatively few people are working, and so in the last X amount of time nobody has logged in. That's not ridiculous, right? That is a potential scenario that you could expect, you could foresee, and if you see the alert and that's why it is, don't panic. The final option, and I say final because this should be the last thing that happens, is customer support. If users are complaining to the support team that something is broken or something is slow or they're otherwise not able to use the software in the way that they want to use it, that's a big hint. That's one way to discover the problem. Automated monitoring maybe can't find everything every time. You don't want to rely on customer support as a primary mechanism, but your organization should have a way for customer support to report things so that it becomes a priority, as opposed to they just try to hassle people individually. Write a message to your favorite developer and hopefully they write you back. That's not a great mechanism. There needs to be a formal way for them to submit an item and say this is a problem and we need help because we're hearing this from actual users whose experience matters. Okay, suppose we have detected a situation that we think that something should happen. There are basically three ways to respond: alerts, tickets, and logging. An alert is, somebody has to take action now, or at least as soon as possible. Tickets, somebody should take action soon. That's in the next hours or days, depending on what it is. And then there's logging, which is, this seems weird. We're only going to look at it if we want to find out sort of what happened later, diagnostic purposes or forensic purposes, if something did in fact go wrong. Right. So alerts are typically the kind of thing that I've been talking about so far, which is nobody can log in. Right. We were unable to launch a new instance of a service, and that's a problem. Somebody needs to address that. That's an alert kind of problem. And then there are the ticket kind of problems. You could also think of tickets as like manual process kind of thing, where we're sending a reminder that says we need to do something. So payment failed, for our bug tracking software invoice. That's not something that's critical. We need to pay that invoice. That's the correct thing to do. But we don't have to take action on it right now. It can wait for Monday morning. It doesn't have to be done on Saturday night. And then the logging things are, again, we don't think anything is actually wrong. Nobody needs to take action. We just need to look at this if something does turn out to be strange or does turn out to be an issue. A common bad situation is logs as tickets. You do not want a situation where you're just dumping a log into a ticket and expecting somebody to read it. We should be writing some code that scans the logs to identify the stuff that is important. Okay. So alerting. Alerting is just what I said. It's a person being notified about a problem, and we often talk about it as a metaphor of pagers, as in the small rectangular box that wakes up the doctor when the patient needs them. Except now we're the doctors and the patients are software. So the person who's on call or on duty or on shift, however you want to phrase it, when one of the conditions for alerting is fulfilled, gets notified, and that usually results in some beeping and screaming and other cursing as the situation may require. The alert may contain some basic information about the event that has caused it, such as telling service A CPU usage is high, but that's not enough to diagnose usually what's wrong, right? It tells you about the nature of the problem. It tells you this is the situation where the value of this probe exceeds the range that we consider normal, but it doesn't tell you why CPU usage is high, right? It might be normal, it might not be, it might be a problem. We'll find out. Then you go off and you look at the dashboard. And it is very important to be judicious about the use of alerts. Right? Like, what do you do when you hear the fire alarm in a building? I'm guessing you probably don't conclude immediately, the building is on fire and I must leave immediately. This is a life or death situation. More likely your reaction is, some jerk pulled the fire alarm to get out of failing a midterm or something like that. This is most likely because you've experienced way too many false alarms. And therefore you conclude that an alarm is likely to be false. It's a good heuristic because it is likely to be correct. The problem is the consequences of being wrong are, this is a life or death situation. So if there is an actual fire, you probably don't want to say, well, statistically I was likely to be correct. But yeah, alerts and tickets are a great way to make users' pain into developers' pain. Anytime things don't work, when things behave unexpectedly, what have you, if you get paged, that really motivates you to do a good job of addressing the problem and making sure that this doesn't happen again. Now, super critical, OMG, kittens are endangered situations really shouldn't happen commonly, but when they do, it's highly motivating in terms of you need to address this, right? You'll make good processes, you'll have good monitoring, you will test your code a little bit better. But listen, alerts tell you about an incident, they don't tell you how to deal with it. And it's pretty hard for me to give some advice about what to do, about how to deal with an incident, because every incident is different and every has different causes and different solutions, and I'm not going to be able to say, just do this. Although, I suppose if we're on the subject, my own experience is most of the time the problem is caused by the most recent deploy of whatever service is misbehaving, so you should undeploy that, roll it back, go forth and try again. Okay, but let's say that we had an incident and it was dealt with. Learning from incidents requires some sort of incident report, sometimes also referred to as a post-mortem. And the goal of the post-mortem is to try to identify the root causes of the issue and anything that we could learn from this, so hopefully it doesn't happen again. If we don't find the root cause, then there is, of course, a significant risk that whatever problem we're dealing with would actually recur. And if we don't learn anything, it's bad for the company. The same or similar problems will recur, but it's also bad for your career growth because your goal is to solve the problem and for it to remain solved as opposed to, it just keeps coming back and, this is the way life is. So reports are worth doing, even if they're not fun. You might actually enjoy them. I don't mind doing them. I never wake up today and I think I want there to be an incident so I can do an incident report. But if one did happen, then the least of my problems is writing the incident report. So I'll give some suggestions about what I think should be in your incident report and how sort of the process should work. And an incident report should contain a breakdown of what happened, preferably with a clear timeline of events. The purpose is to understand when the problem started, when it was noticed, what actions were taken, when the incident was resolved, and as the famous saying goes, strictly the facts, please. Or just the facts, ma'am. Which apparently the character here, Joe Friday, never said in the show Dragnet. It's like, beam me up, Scotty. Captain Kirk never says that. The closest he gets is, Scotty, beam me up. And so people kind of just get it wrong. Okay. It is important to be factual, right? We're just giving like a dispassionate timeline of events about what happened. And there are two kinds of causes. There are root causes and proximate causes. And this is the most important part, if you ask me, the analysis of why whatever incident we're talking about took place. And proximate causes are things that happen just before the problem or are the trigger that causes the problem to occur. If you remember in a previous discussion about deadlock, we would say, well, a deadlock can occur because thread A acquires lock X and waits for lock Y, while thread B acquires lock Y and then waits for X. The proximate cause in this situation is lock acquisitions of thread A and B because user 1 tried to update a record while user 2 was trying to run a report, something like that. That's a proximate cause. The problem occurred because of this, but it's not the root cause. The root cause is that we don't always acquire locks in a consistent order, and if we did that, then we wouldn't have this problem at all. It's important to focus, as I say, on finding the root cause, but how far do we go in terms of finding the root cause, right? We don't want to stop at just a superficial level, right? If we just say the root cause is, I wrote code and that code had a bug, the solutions to that are like, don't do that, or maybe write more tests. They're part of the solution, but they aren't going far enough because we also have to think about things like the test environment is not representative of the production environment, or it's hard to assess the impact of a change before it goes live, or maybe the real problem is just a lack of knowledge about a particular subject. Like we don't know enough about concurrency and therefore we didn't think about the nature of the problem that we encountered, and with some more training, with some more education, or use of a different tool for assessing our program, we might actually solve it. And so Toyota, yes, the car company, uses a model of 5 whys, which is to say that you should ask the question why 5 times to make sure that you get to the actual root cause. I don't think it's necessary, just speaking for myself, to always use exactly 5, but it is a question to be asked to make sure we're looking at the right level. User judgment. If we ask the question too few times, we get superficial answers. They don't really tell us what's going on. They don't give us any sort of deeper understanding about what we should do. If we ask the question too many times, then we end up at answers, like root cause, like writing code is hard, and we end up debating whether computers were a mistake. That's not helpful, right? Debating things that you cannot change. Are we wrong for having ever taught Silicon to think? That's not helpful. That's not going to solve our problem today. So we're looking at things at too deep of a level. So what do we do in the short term and the long term? All right, we need to make some recommendations as the author of a report that says these are our action items, these are the steps that we're going to take to prevent the problem from happening again. Sometimes it's very simple, we just fix a bug, maybe monitoring and alerting needs to be improved, but ideally we can think of something that prevents this kind of problem from happening again. We have some test bench deployment stage that catches performance problems before they go to production. As Smokey the Bear says, only you can prevent forest fires. You need to take the steps that are necessary to prevent this problem from happening again, and action items are those steps. But they have to be realistic. Action items have to be something that you could actually do. You could say that you could prevent the race condition problem by simply rewriting all the company code in Rust. that's probably not going to happen. You are unlikely to get that much buy-in from senior management at your company that says we should stop everything for a rewrite in Rust because it prevents a concurrency problem. I mean, it does solve the problem. I won't be mad if you say this is actually a solution. I will be mad though if you tell me it's realistic. When actually you're talking about thousands and thousands of lines of code that have been written by dozens of people. That's not going to be an easy thing to do, to rewrite it all in Rust. Now maybe you could say from now on new services should be in Rust. That might be plausible, but you're not going to be able to convince everybody to rewrite everything. And whatever you come up with in terms of conclusions and recommendations and stuff like that, they're not always going to be sort of mind-exploding, I can't believe I never thought of that, inception moment revelations, right? Reports sometimes result in boring conclusions that say, yes, our test infrastructure is inadequate for this situation, we need to improve it, this is what I think we should do. That's fine. We're not expecting anything life-changing as a result of it. Yeah, lessons learned are important, but it's also important not to have things in there that should not be in there. So I put a few items here. I put number one, irrelevant detail. This is fairly straightforward. Anything that is in the report that isn't helpful, doesn't matter, is just wasting time, reducing the likelihood that people read it or take action on it. We should also avoid speculation. Speculation is often wrong, and sometimes we are sort of forced to proceed without being totally certain about what happened or why. And educated guessing and theorizing is okay, but speculation is just guessing without any basis. And finally, the report should not contain blaming. You'll notice I put blaming on there twice, and that is on purpose. Blaming and shaming are counterproductive for learning and changes. And really, I mean, I put it on there twice with intent here. You might be wondering, why is blaming bad? Let me put it like this. If you know you're going to get in trouble for an incident, it actually incentivizes covering up incidents or denying a problem as opposed to admitting that the problem has occurred and dealing with it and trying to figure out sort of lessons that we could learn. That's not what you want. Similarly, it incentivizes people to spend time shifting blame to others or arguing about who's really at fault, who introduced this bug or which team is responsible for checking this service. That kind of thing is, again, counterproductive. There are lots of articles out there about, say, the medical field where blaming results in much worse patient outcomes in the medical field as opposed to a learning kind of culture, right? A learning culture says we're not interested in assigning blame, we're not interested in deciding whose fault it is, we're interested in what are the lessons we can learn and we can improve based on this. That's easier said than done, and to a certain extent, every company says, oh yeah, we have a learning culture, we don't blame them, but you'll only know that for sure when you see what actually happens when you actually have an incident and you see how that is handled. Now, performance problems or downtime are not the only things that we need to look for. There's a very serious risk when we are running our code, always on, always available services, that attackers may be abusing our platform and systems, right? Having some always available server on the internet to which other people can connect and do stuff, that is actually a potential security concern. You can run your program with tons of security vulnerabilities offline and you can feel like the problem can be managed, but in real life an online service is potentially exploitable from anywhere. So the risk is very large. All kinds of vulnerabilities are potentially a problem. There's kind of an unlimited amount of things that can go wrong, but I want to talk about two very specific ones. I will talk about code execution and injection and data leakage, also called information exposure. So we're going to talk about the code execution thing first, and it's exactly what it sounds like, which is attackers run their code using your platform. They mess with your data, they send spam or harassing email to your customers, they take services without paying for them, mine Bitcoin at your expense, any number of things which you probably do not want, and you would be embarrassed if that actually happened on your system. These kinds of things can be company-ending events, so we have to be very careful about them. I'd actually like to go on a quick digression about monitoring and seeing it in real life with a real-life example of detecting the very bad behavior of crypto mining. Right? We're talking about abusing free services for fun and profit. And our source here is an article that's linked in the lecture notes about how some security researchers found malicious actors using build and deployment systems to mine cryptocurrency. The attack in question is about abusing the free as in no charge, free as in beer, CPU time and other resources that cloud providers offer. And this is nice of them, and they are presumably there for non-nefarious purposes, right? The course notes for this course are auto-compiled using GitHub Actions, and that is basically GitHub giving us some free CPU time, some free resources to take the LaTeX files and make the PDF output. No longer offering free resources like this does make it a little bit harder for attackers to abuse, but we also have to worry about a scenario where an attacker gets inside your network and uses the resources that you're paying for to mine cryptocurrency for them. Yes, if they do that, it's costing you money, but it's also hurting your actual operations potentially because resources are limited. And if attackers are using your CPU time to advance their own financial interests, it's a problem because the CPU time that's not going to your customers that they probably want to serve their requests. So the attack in question here involves bypassing some sign-up limitations, including defeating some CAPTCHAs, the things where click on all pictures of traffic lights or find all the buses in here that are trying to differentiate yourself from a bot, and using a script to run the web browser to make it look like a human is browsing the page and clicking on the buttons. And that's one potential attack. A malicious user could swamp your services with fake signups. Typically, there are some resources that are dedicated to creating a new account, and if a malicious actor is creating accounts at a very fast pace, we might not be able to keep up, or at least every database is filled up with a ton of junk data, making insertion and retrieval potentially slower than it otherwise would be. So in this specific attack that we are discussing, the attackers mine cryptocurrency, but kind of inefficiently. It's not the most efficient route given the number of accounts that are required and given the number of accounts and how much each of them can do. It's not great, right? There are limitations on the free tier resources, and the attackers would need a few thousand free accounts to mine one of the coins that is being discussed here. I don't recall off the cuff without looking in the article exactly which coin it is. So the security researchers did some estimate, and they said it takes about $103,000, all figures US dollars here, of resources are used to mine one coin, produce $137 approximately in value. At least at the time of writing. For all I know, this is a crypto coin that has crashed in value completely since the time of writing, and it is in fact now completely worthless. But who knows? In any case, given those figures, that represents a 0.13% return, which is kind of nothing to write home about, right? That's not actually great. Except, it's GitHub or somebody else who's paying the $103,000, so the return on paying nothing to get 137 is basically infinity. It's free money. Okay, you probably had to do some work to, compromise the system and set up and run the stuff, but let's call it practically free money, or as the saying goes, it's free real estate. Now, there's a little bit more to it, right? Like if somebody looked at running jobs and they saw a container that was called mine crypto LOL deployed, it would certainly look suspicious. So it's Linux 88884474 instead, and it generates random GitHub action names and to make it look much less suspicious. And that kind of thing makes it a little bit harder to identify rogue malicious processes at a glance. It's not always as easy as, I say, finding the one that's called mine crypto. Something like crypto mining actually might be somewhat easy to identify as compared to certain other kinds of malicious activity because it's very CPU intensive. So if we see a bunch of containers that are using a lot of CPU without any explanation or without knowing what the service does, that might actually be a big hint that says, we should take a look at that. And when we do that, we will identify, something weird is going on here and we should do something about it. But if a container is just sort of sitting there quietly and sending your company secrets to the competition or to extortion rings or something like that, that's much harder to find and it might be very, very costly. On that subject, information exposure. Information exposure is bad, both for your reputation and for your bottom line. The European Union has a regulation, GDPR, the General Data Protection Regulation, and it has pretty big fines that can get rather expensive. And you can take a look at the enforcementtracker.com website if you want to see. If we do this in class, we'll have an opportunity to browse around and play a little bit, and you can see sort of which companies have had their wrists slapped or gotten a big fine. At the time when I wrote this, the current record holder for the largest fine was Amazon Europe, which is based in Luxembourg with a fine of 746 million euro. Which is just over 1 billion Canadian dollars using the exchange rates from October of 2022. That's not exactly pocket change, but for a mega corporation like Amazon, they can certainly afford it. But all things considered, I think they would probably rather have the extra $1 billion in quotation marks shareholder value. Other big offenders who you might expect to see are in there: Facebook/Meta, Google is in there, but also H&M. Yes, the clothing store is a top 10 in the largest fines ever given out, at least at the time when I pulled this data in October of 2022. And you will notice that a lot of companies are getting fined for things like insufficient technical measures. That is to say, they don't do enough, they don't have enough safeguards implemented in what they're doing to ensure the data doesn't get into the hands of the wrong people. And you've probably heard me talk about this, and sort of one situation that I mentioned already was this potential nightmare of personally identifiable information getting in the logs. And as long as the logs themselves remain secure, it wasn't a problem. But if an attacker does, for some reason, get a view of the logs, then they have a one-stop shop for everything that they are not supposed to see. And as I said, that was an example of a security policy backfiring. It was too difficult to debug and trace the code, so excessive data was put into the logs. It's like when users write the password on sticky notes. If your security policy is too strict, you may end up actually just sort of making your own life miserable. So defending against vulnerabilities is also partly automatable. This could have actually been in the previous topic about configuration, but I think it made a little bit more sense to put it at the end here to both wrap this specific topic up, but also to relate it to the security thing that we just spent a little bit of time talking about. And there are companies out there who have tools that check your code for libraries containing versions with known security vulnerabilities. And this is transitive. So if your app depends on a library and the library depends on something that has a vulnerability, this is noticed and reported, and you can end up with a nice report that says, here are the things that potentially need to be addressed. Unfortunately, each vulnerability is treated differently by different vendors. They have a severity, and the severity might suggest that updating from version X to version Y might be helpful, but the authors of the library might not choose to do it, right? The library might be stale, it might take them a long time to do it. Changing it might introduce breaking changes. So an upgrade might be more painful than just changing the version number automatically and rebuilding, and it might also take a while for that new version to be released. And so if it does take some time, in the meantime, you might need to implement some mitigation of your own, or just sort of keep an eye on when the patch is released. To support your waiting for upstream, your vulnerability checks usually give you some option to ignore or snooze the alert. And because that option exists, it's probably tempting to just hit the button whenever your deployment fails because there's a security vulnerability, or your pull request fails because, well, you need to update such and such a library. You can say, I'm just going to ignore it, and I'll deal with it later. Yeah, but later has to happen. Later can't be never. So we have to be mindful of the fact that choosing to ignore vulnerabilities is dangerous. We need to do it only when we have kind of no other opportunity. And as with sort of everything else that we've talked about so far, like build and deployment, checking for vulnerabilities and potentially even patching them should be an automatic process as part of your build and release procedures. It is possible to configure tools like Renovate or Dependabot to generate PRs that contain patched versions of libraries, and this is actually quite beneficial because it saves you from investigating and trying to figure it out. So you just wait and observe when Dependabot creates you the PR or Renovate creates it for you, and you can look at it, you review it, you check it, and then you know what to do. So all of this is to say that keeping your software running and keeping it secure is a pretty big challenge. There's a lot of stuff that needs to happen to make sure that everything goes right and that nothing goes wrong, and that you're not getting everything exploited by malicious attackers who are trying to use all of your code, all of your infrastructure to mine themselves some cryptocurrency. So it's an ongoing thing. It's an ongoing battle. A lot of the skills that we've talked about in terms of performance monitoring and dashboards and all of that tie in quite nicely to this idea of, well, keeping the lights on and keeping it running is an ongoing chore. So hopefully this has been kind of an interesting digression. It is an unusual way in a way to end the course topics because we're talking about software operations as opposed to programming for performance more directly, but I think you can see how all of these things are related and why the things that we've talked about in this course and the skills that we've learned, particularly in the later topics, are in fact very important in terms of keeping your service going. So that's it for this topic. And the next and final thing is just a bit of a wrap up.